Well, I'm a little bit short on time tonight, so I don't have any plexers for you, but I do have a lesson for you on actually applying the derivatives that we've been learning in class. And it's kind of cool because especially if you're in physics, you've probably already done this before, and this will be a little reminder of what you've done in physics and maybe presented a little bit differently with the math involved. But anyway, the topic of this particular lesson is the topic of motion, and we explore this a little bit further in calculus, motion in two directions, or in two dimensions. But in pre-calc honors, in the first part of calculus, we talk about motion in a straight line, and sometimes it's along the x-axis, sometimes it's up and down, sometimes even forward and back. But this is one-dimensional motion in either one direction or the other along a straight line. Okay, and so in everyday life we have things that we see that move along a straight line. We talk about a car moving down the road, or even if you're playing pool, let's say say on a pool table we have different objects like the cue ball or any of the other numbers 1 through 15 that roll around the table and they go in a straight line. Okay, so and then vertical examples would be, let's say if you cannonball that shoots up in the air, straight up in the air, or let's say a diver that jumps off of a building and just kind of jumps off of a cliff into the water, not off of a building, but you know what I mean. So something going straight up and down, or cannonball goes up and then comes back down. So straight line motion. We've even talked about this before, where we talked about the parametric equations and such. But nevertheless, we have motion in a straight line. And as you read down, you can see that if you read through this packet, you get the information that you need as far as an object moves, its position is a function of time, and the position function we're going to use s of t to represent the position as a function of time. And for example, here if we have s of t equals this function right here and t in seconds, s of t, we're being told that what position on the horizontal or vertical number line the particle occupies at different values of t. So in other words, we'll use that example right here. S of t equaling t squared minus 2t minus 3. So if we would like to know the position along, let's say that this is the position of the particle that travels left and right along, let's say, the x-axis. And if we write the x-axis here, we know that the position at time 0, so that's the first thing it asks us to find. The position at time 0 would be, you just plug in a 0 for t, and you end up getting -3. So you would put a dot right there at -3, and you would put t is equal to 0. Okay. Well, it's also asking us to find the position at 1, and so we can plug a 1 in. 1 squared minus 2 times 1 minus 3, and that's 1 minus 2 is -1. 1 minus 2 is -1, minus 3 is -4. And so the position of the moving object at t equals 1 would be right over here at -4. And so we can use these position functions to represent, to show how an object would move and where the object would be at a certain time. So you can see that from t equals 0, you start the clock, 1 second later, the object has moved to the left 1 unit. Okay. And then go ahead and find the position at times 2, 3, and 4, and then you can pause the video and do that, see if you can figure out what's going on here. I'm going to go ahead and do the work right up here. S at 2 is 2 squared is 4, so 2 squared minus 2 times 2 is 4 minus 3, so you get -3. So at t equals 0, then t equals 1, and then we're back here at -3, so this particle has changed direction somewhere over here, we don't know where, but it's back there at -3 at t equals 2, and then the position of the particle at t equals 3 then would be 3 squared minus 2 times 3 minus 3. So 3 squared is 9. 9 minus 6 is 3. And 3 minus 3 is 0. Okay, so now the particle is moving over this way, and it is at 0 at the time t equals 3. Okay, and finally, s at 4 would be 4 squared 16 minus 2 times 4 is 8 minus 3, so 8 minus 3 is 5. And so all the way over here at x equals 5, or this position s of 4 is equal to 5. So we say the position is at 5 when time equals 4. This is t equals 4, here's t equals 3, and we can track the position and the movement of an object based on that function that gives us the position at any time. Alright, well, let's take it a step further and see how we involve derivatives in this. When an object moves, its position changes over time. And so think about the derivative as a rate of change, the rate at which the function y is changing. In this case, its position changes over time. Okay, so what does that mean? It means that we can say that the velocity function v of t is the change of position over time. Okay, and the change of position over time is called the derivative. The derivative is a rate of change. And so we are defining now that the velocity of this object, the velocity is the derivative of the position, the rate at which the position changes over time. Okay, and another thing to define, which is kind of cool, is that if we know the velocity, or at least the sign of the velocity, we can determine in what direction the object is moving. And let me have you write this down. This is a really important concept. Velocity gives us how you move, or how the object moves. Velocity is how you move. Acceleration, and we'll put that right down here, acceleration, we'll get to that in a second. Acceleration is how you push, and we'll do a demo on that in class on Thursday, Friday. So anyway, we can see that if the velocity is positive, the object moves to the right. So velocity positive, the object moves to the right. Velocity, if that's if the object is moving left and right. If the object's moving up and down, then velocity positive means that the object is moving up, and velocity negative means the object is moving left or down, depending on what direction. And then when the velocity is 0, that means that the object is not moving. It's stopped. Whether it's going up and down, left or right, it's still stopped when the velocity is 0. So then we get to, and I know I'm kind of giving you a lot here. We're going to start doing some problems on the next page, but just giving you some background here, so there's not a lot for you to be doing right now. Speed, however, if you have a highlighter, that's kind of nice. Speed is not synonymous with velocity, meaning that speed and velocity are not always the same. Speed and velocity are only the same when the velocity is positive. Okay, so speed doesn't indicate direction. So if you could please remind me in class to give you my example on speed, I will do that. So speed does not indicate direction. Let me go ahead and highlight that whole thing. And so we define the speed function as the absolute value of the velocity. So in other words, speed is always going to be positive. Okay, and the speed of an object must either be positive or 0. So yeah, if the velocity is 0, the speed will be 0, but the speed of an object can never be negative. Okay, and then the acceleration is the rate of change of the velocity. So one last thing before we kind of start getting into some examples. Acceleration is the change of velocity over time, so the rate at which the velocity changes. And again, you're getting the background now. Just try to get comfortable with the notation and everything, and in class we'll do some more examples. Given the position function, we can determine both velocity and acceleration. On your cars, you have two devices to change the velocity. Okay, you have the I'm wondering if you could figure that out. What two devices that can you use in your car to change the velocity? It would be the brakes and the gas pedal. Okay, or the brake and the gas pedal. Okay, and we'll talk more about this stuff here, acceleration function like this. Yeah, I'm not particularly fond of this chart here, so I'll get to that in class. Okay, give you a better idea, better visual on that. All right, let's see. Let's just go ahead and move on. Forget about the last part there. I'm going to actually go ahead and pause or stop the video, and I'll start the next one on the second page.